Today, we're diving into a new model that teaches AI something we humans do all the time, thinking before we act. It's called the Vision Language World Model, and it's all about giving AI the foresight to plan complex tasks, not just, react to what's in front of them. I mean, think about it. We've got AIs that can see and react in a split second. That's amazing. But what happens when you ask one to plan a complex, multi-step task? Like, say, cooking a meal just from reading a recipe. It falls apart. That kind of long-term planning requires a different kind of intelligence. And honestly, it's one of the biggest hurdles in AI right now. So here's how we're going to break this all down. First, we'll get a handle on the planning problem itself. Then we'll introduce the model built to tackle it, the VLWM. We'll look at its two very clever modes of thought, see how it actually performs in the real world, and then wrap up with what this all means for the future of intelligent systems. Okay, so to really get why this new model is such a big deal, we first need to understand the problem it's trying to solve. What's actually holding AI back from true human-like long-term planning? Right now, most AI models are kind of stuck in the present moment. They can see a scene and react to it, but the real goal is to get them to think more like a chess master, abstractly considering a whole sequence of future moves and their consequences way down the line. And look, this is a really, really hard problem. Just prompting a large language model doesn't work because it has no connection to the sensory world. Your standard vision language models, they're trained to see, not to predict what happens next because of an action. And video generation models, they are computationally massive, and they waste so much energy predicting every irrelevant pixel, like how a shadow on the wall might move, instead of just focusing on the actual goal. So, how do we get around all of this? Well, the researchers behind the Vision Language World Model came up with a pretty radical shift in thinking. What if we change the fundamental way an AI represents the world? Instead of trying to render millions of future pixels, the VLWM predicts future world states as simple text descriptions. Now, this is a total game changer. It's way more efficient, it's human-readable, and it lets the model tap directly into the incredible reasoning powers of large language models. But to train a model on all the video on the internet, you can't just feed it raw pixels. That's insane. You need a smarter way to summarize all that data. The solution these researchers came up with is a really clever method called the tree of captions. It automatically creates this layered text summary of a video, capturing everything from the high-level goal all the way down to the tiny granular actions. This creates this really powerful and elegant data pipeline. First, you take raw video and compress it into these text-based trees of captions. Then, you use an LLM with a self-refining process to pull out structured plans, basically recipes of goals, actions, and outcomes. And get this process created a massive dataset of 1.2 million of these goal plan trajectories to train the model on. Okay, so what's really cool is that this training allows the VLWM to plan in two totally distinct modes, and it's actually inspired by human psychology: a fast System 1 and a slow System 2. System 1 is that fast, intuitive mode. It's like an expert's gut reaction. It just generates a plan directly. But System 2, that's the deliberative mode. It internally simulates multiple plans, it weighs their outcomes, and then it chooses the best path forward. It actually thinks about it. Now, the engine behind this reasoning is a Critic model, and it's trained in a self-supervised way, which means it learns without any human labels, just by comparing the predicted outcomes of a plan to the actual goal. It literally teaches itself to spot the difference between a good plan and a dead end. So it's a really impressive architecture on paper, but does this whole dual mode thinking thing actually work in practice? Let's take a look at the results. And the results are pretty striking. On a standard visual planning benchmark, the 8 billion parameter VLWM outperforms VidAssist, a model that's nearly 9 times its size. This isn't just a little bit better, it's radically more efficient performance. But maybe the most compelling evidence comes from a place called Planner Arena. You can think of it like a blind taste test for AI plans. Human evaluators rated plans from all these different models, and in this arena, the reflective System 2 planning of VLWM was the clear winner, and not just by a little, by a large margin. And this number right here, this is the difference that thinking makes. The reflective System 2 scored a massive 27% higher with human evaluators than the purely reactive System 1. It's about as definitive proof as you can get. Humans prefer plans that are made with reasoning. And this isn't just for understanding videos either. On a benchmark for robotics, VLWM again hits state-of-the-art results. And this is so crucial because it shows the model's planning ability can actually generalize to physical agents, a vital step if we ever want to build smarter robots. So let's pull all this together. What are the key things you should take away from this research, especially if you're a developer or a researcher in this space? First, using language as an abstract space for world modeling is a seriously effective and efficient strategy. Second, this dual-mode approach, combining that fast, reactive planning with slow, reflective reasoning, is an incredibly powerful paradigm. And third, and this is a big one, this entire system learned from massive, uncurated video datasets without needing explicit reward signals. That just opens up so many new frontiers for training. However, there is one critical thing to keep in mind. The entire system's performance, everything we've talked about, hinges on the quality of that very first step, the tree of captions. If that initial text description misses a key detail in the video, the model will never know it existed. The classic rule of garbage in, garbage out is in full effect here. Ultimately, this research moves AI beyond simple imitation and towards genuine reasoning. So the question this leaves us with is this: what are you going to build with an AI that can actually think before it acts?